So this is the week 3 review. So as you know, I'm going through this book, Hands-on Machine Learning, and this video. So first we'll review or a summary of what was the week 2 review. So we somehow got into a corporation, what different questions we need to ask, performance measure, what are the different performance measure, how we can get the data, visualize the data, uh, gain some insights. And then one important aspect of that video was how we can divide that our test and train, how we can split our data into that. So we learned 3 ways to do that. Then after that we some more visualization, and post that they were how we can define the correlation between two columns in there. Okay, then again plotting that to see which one is the correlation. This was more or like looking like some model it was trying to form, so the correlation was high in that. And then we saw okay how we can experiment with attribute combination. So we'll start from here today. So this is the week 3 review. So really, if the amount of code that I've done, right, it has become too messy. So I thought, okay, I will create a separate notebook and try to jot down the points. Okay, so yeah, so we'll start with experimenting with attributes. So what it means by that is, say, two of the columns, right, when we try to train the model and see okay which one is playing a bigger role in defining that. Say here we are trying to find this value, say. Okay, so here we are trying to define this median house value that we want to find. Okay, so longitude is playing a big role in finding this value, or this one is playing a bigger role in helping predict this value. Okay, so many times it can happen that some of the columns, say just for an example, population is not playing any role. If the population is changing, still we are not seeing any change in the median house value. Okay, so what we do in that case? So here what they mean to say is, say two of the columns, right, who are like not contributing that much to the model, can we define some operation in between them? Say we multiply them or we divide them, something like, okay, say households and the population, these are not contributing much. Okay, or say only household is not contributing much to the median house value. Can we define something like household per population, just as one extra column which will have all those values? And can it happen, or we can see that okay, if they are playing role in somehow helping us determine the median house value in a much better way. Okay, so that's what it's here. So we combine those two dull columns which are not contributing that much and see if some correlation can help us get the sprite rate. Okay, suppose that it was the data preparation. So as part of data preparation, first we have to do is we have to separate the label. So label, what I mean by label is this is the total data, this is what we are going for, what we need to find. So we'll put all this in one table and this one in a different table. So here we are going to drop that value. Okay, so housing will have without that median house value, and one more table, the housing levels, which will have only that value. Okay, now first starts with data cleaning. So many of the machine learning algorithms, right, if you they expect you to give numbers or text or in some form. Okay, but it can so happen that in our whole table there are no values, none values, and it can happen that it's a raw data. When someone trying to create the table, they didn't find any value for that particular column, they will leave it as blank. That's what when you do a tf.info, right, to get the information, you will see something like, say, total bedroom. So it's 20,640. Okay, these are the total number of rows we have, and out of which 20,433 are non-null. Okay, so this means somewhere around 207 of them are null. So now what we are going to do, because if we feed this model, if we feed this data to the model, right, it might go wayward because it doesn't understand what is that not a null value, what to do with it. Okay, so in case of that, we can do some of the things. One is just directly drop those values. Drop those values means those rows which have not null values for total bedrooms, right? Just drop those rows, okay? Or one more option is to drop that particular column only, okay? This depends on with the as much as we play with the data, right? We try to understand, okay, if this is playing a huge role in determining the label, okay, the median house value. In that case, we can't drop it directly. So it depends. Yeah, these are the options. And now again, one more option is to get the median of the value and put it there. So it's something like, okay, something like what is current situation happening in schools, right? When we are not able to take the final exams because of this COVID scenario. What we are doing is all the previous exams that children has given, okay, just average it and give it to him, something like that. In middle, however, it will just give you a picture of what those values are. So in the same way, if you don't know some of the values, right, all the existing values, just average it out, just give you some basic price of rupees versus dollar, like say 70 or 75 something. If you average it out for the past 1 or 2 years, it will come around 70. If we have some blank values, put 70 in there, okay? And always it's an iterative way. You can try this out and see what's happening, try this out and see what's happening. So it depends. Now first, this was mostly related to the numbers, okay? Now what about the text and the categorical? So here mostly these are all float types. One is only object is ocean proximity, but you can have something else also, something like an address. So then again you need to decide, is that going to play any role, or can I modify that? Because mostly this machine learning algorithm, right, they want to take number. They perform pretty well when they take number. When you some of the algorithm, I think they don't consider text values also. They want in numbers, okay, integers or floats or something like that. So then we need to convert. So one of the way for the categorical columns is known as the one hot encoding. So say color here, okay, some has red, some has blue, some has green, some has again blue, okay. Now if you feed this to the machine learning model, right, he is not a human, it will be difficult for him to understand, okay, red, blue, green, these all things. So obviously it understands numbers in a much better way. So what we do, we separate this, okay. So this is color red, blue, green. So for the number one, it was red. So red is 0, it's not blue, it's not green, so it's 0 0. Same way, if it's a blue, it's 1, other two, it's 0. So that's how we try to encode it and feed it to the model, okay. That's what the intention of this is, to prepare data for the machine learning model. What type of data it wants, right? We try to create our data in that form. Now then comes feature scaling. So this is one more important aspect. So if you see, that's right. So here if you see the median house, no, this one, the median income, it ranges, this one is the minimum, okay, this is the max. So minimum is this one, max is this. So do you think it is possible to have a 15? It's in dollars, so $15, it's wayward, right? Only $15, that is the maximum, it can't be. So again, when we went to the team and we asked, okay, what is that, whoever prepared the data, they told that, okay, we have done scaling because the numbers were pretty huge. It was like dollars and something, so they tried to scale it. But again, they have scaled this one to 1 to 15, but the other ones has some other values, 35,000, 36,000, something like that. Okay, so now when you give it to the machine learning, he's seeing somewhere 15 is the maximum, where for some cases it is like 39,320. So it will be difficult for the machine learning model to figure out, okay, 15 actually doesn't mean 15, it is much more than that. So you have to explain. So to remove all those confusions, right, what we do is we do scaling. So we scale all the columns in certain way so that 15, when we say, okay, it means same for everyone. Say for this column also, when we scale it around, it will come around say 15, okay. So we can understand this value and this value are near about, okay, there is not much of difference in the same scale. It's like we have won this small scale and we are trying to calculate all the things based on this scale only, okay. Everyone does not have its own scale. Based on this scale only we are dividing, so that when we tell machine learning the algorithm take this scale and that's how the things are scaled, he will understand it rather than giving him 100 scales to define 100 different columns, okay. So for that also we have two ways. One is the min max scaling and one is the standardization. So min max scaling, what we do is we take each value in a column. Okay, for that particular column we'll take the max value, say 39,300, which is the maximum value. So we divide all those subtract all those numbers with this max value and divide it by max minus min. Okay, how much is the difference? And one more way is known as standardization. What we do is, for this one we take the mean, say mean is 2635. Okay, so any other value, say 1447 is the value for a particular row. So we subtract this from mean and we divide it by standard deviation. It's here. Okay, we divide it by this. So we subtract these two and divide it by this one. So they both have their advantages. So this min max rate, one of the problem with this guy is that it's very affected by the outlier. So say we have 100 rows. Okay, all of them means 99 columns. Rows have values 1 to 15 between them, but for one of the row it's 100. Now maximum becomes 100. Now when we subtract minus 100, say 1 minus 100 minus 99 divided by 100, it will become very small. So all those values from 1 to 15, okay, which are the real true values, 100 seems like a odd value. It should not be that value. Okay, so it's affected by that a lot. So it becomes very small. That 1 to 15 hours becomes very small value. Okay, whereas in case of standardization, it's not that much affected by the outliers. We take the mean and you see the standard deviation, it's not that much affected. Okay, so you can use this one. So it depends, if the outliers are not there, you can use this one also. You can use this one as well. Now, okay, so we learned different ways of cleaning the data, right? First filling the NA values, then categorical, how we can treat them, how we can scale them. Now, how we are going to apply this on our data, okay? So rather than applying them one by one, so first we are trying to fill with median, then doing this, then doing this. So Scikit-Learn actually provides us a way to do that. So what is it? It's known as a pipeline. So say first I'm defining it as imputer. So what is imputer? It's the same thing. We are trying to fill all the NA values in the full table, okay, with median for that particular column. So we define it. We just give it an imputer. What we want to do with that. I'll leave this for now, combined attribute add or something like that. Okay. Now, one is the standard scalar which I was talking. So this is the standard scalar which you want to place. So what will happen when we will call this num pipeline.fit transform? What it will do? It will take our row. Okay. First, give it to the imputer. So what it will do? It will search for all the NA values in a column and fill it with the median. Then it will go to this one. Leave it for now. Then again, it will come here, and for that particular column, it will try to scale it. Okay. In that way, it will modify all the values that is present in that particular table. So this is what this fit transform does. Okay, but this all you can see that these are for the numerical columns, right? For categoricals we thought of doing this one hot encoding. So how we are going to do that? So there is again a way in Scikit-Learn where you can do both the number also the category. So here what we are doing, so we are saying it column transformer num pipeline, the one that we define, and the num attributes. So these are mostly the attributes or the columns which are numerical. So, okay, so which are all numerical, right? For these ones, apply this pipeline, and for the categorical ones, which I am giving it here, the ocean proximity. This is the only one which seems like a, sorry, this one. Okay, what we want to do is apply one hot encoding, this one. Okay, so it will run apply all on the complete data. Okay, and this housing prepare that you can see, right, it will have the proper data, means all clean data, no null values, no categorical values, all in proper scale, this data. Okay, this is the data that we can give it to the model. Okay. So one more important aspect which they explained in this book was using this scalar. So they say that this scalar, right, has a uniform way of applying it. So whatever you use from scalar, right, it has this just 2-3 methods which you can use, and all the things, all the operations from the scalar you can do with that. So First is fitting. So fit is mostly something like trying to understand from the data. So say here, when we set median, right? So in case of fit, what it will do, for each column, it will list out what is the median. Median, it will try to do that. Okay. When we set transform means changing the data. Now once I have found the median, I will modify all the NaN values with the median. So that's what transform is. So there are two separate functions also. You can call num pipeline dot fit, then num pipeline dot transform. Whereas they have created one function only which will do both the things. Okay. And later we will see one more operation, but there are different as well, different methods as well. But for now, this much is useful. This much, if you know, it's fine. Okay. So now, okay, when we have prepared our data, now we feed it to our model. So how we are going to do that? So again, I told you first we define the things. So something like here pipeline we have defined, here also something like a decision tree regression. Just think of this as a machine learning model which learns and then helps us predict. Okay, so we define it here. Then we say fit. See here we are not using transform because we don't need to transform anything. It has to learn, it has to find that correlation. Okay, the data and the label that I have given. So here the data I am giving him, the label I am giving him, it's trying to learn. Once it learns, I am telling it to predict it. But if you see, whatever data I am giving it to learn, I am giving the same data for him to predict. He has already seen the data and I am giving the same data. So this is one of the way just to test the model, okay, that how it is working and how it is going on. So yeah, it's training anywhere on the training set only. So this is just a way to see, okay, how my model is preparing before giving the test set, or can we do something better in that or not. Okay, so one, what in what aspects it helps is, let's see. So it predicted, okay, so actually the house level was supposed to be this, it predicted this. Then we are trying to see the error, what is the difference between these two. Okay, root mean square error. So we got 0 0. So this means whatever data we gave it for learning, it learned it so well because it's something like it memorized everything. Now when we gave the same question paper to him to help give answers to those, it gave everything 100%. Okay. But this is a problem. Right? This is what we call as overfitting. So something like you can say, yeah, let's say this. Okay, sorry. Yeah, see, say my points were something like this. I told him to learn it. It learned it like this well. Now it is so much fitted that if a point is here also, right, that should have been if I give him a point to predict for this one, okay, which was actually supposed to be here, it will give this one because it is so tied down to the value, right? If any other value here and there, if I give him, right, it will learn it. If there is outlier also, think of here is one more point, okay, it was an outlier, it should not be this high value, it should be only this much, but I gave him, but it learned so much that it came here. Now all the values near to that, if I tell him to predict, it will predict this high, but this was not supposed to happen, right? Because it learned it so well. See, in a data, it's expected, I mean, it's expected, it can't be that 100% it should be able to learn. Okay, as a human also we make mistakes and it's expected. Okay, so it can't be that 100% that model is correct, you can't learn everything. So some sort you can say as in a stock price, okay, stock market. So every day, till now, say till today, I taught him this are the news and these are the stock price of these values. It learned everything, okay, how to predict it. Now the next day, something if new value comes, it will be like, I have never seen that value, I don't know. So it should be able to give you values, okay, it should be that it should be able to perform in this new data. That is what is the challenge in machine learning. You can teach him however he teaches. Something you can say as a student, okay, before the exams, I gave him a question paper. He learned from that, okay, he understood, he trained, but he should not memorize it, because if he memorizes that question paper in the test, if they give some other question paper, he will fail, right? What he should understand is the logic behind that, okay, that is very important, not the memorization part of it. The logic behind it is very important. So that's what happens in machine learning also. It should not happen that it should learn all those. If it learns in the training data, and then when we try to test him, if he performs really bad, then there is no point, right? So so here it gave 0 0. Now it can so happen, it's very rarely, it's impossible that we can get error 0 0, but we'll see this other way of testing it if it has overfitted or not. Okay, so till now we used a decision tree to, means that's also machine learning model. There is one more model, that is linear regression. So with that also we perform the same thing. We defined it, then we tried to fit it. Okay, these are the two ways. So now again we will predict, and then error and everything that will also come here also. Okay, now how to test that it is overfitting or not? So there is a way, that is cross validation. So what we do here is we have divided our data, okay, into say 10 equal portions. Okay, so we have 100 data, say we have divided into 10 buckets, 10 10 10 10. Okay, what we do, we train with those 9, okay, and we test with the 1. Okay, so if we have say 10 data, we train it with those. Now the last one, that one is left, I try to test it, okay, how it is performing. Then this was the, you can say, level 1. Now level 2, we select other 9 datas and we pick one more for the testing. So means 10 times we go, each time we'll predict, we pick one as the test set and the other 9 as the training set. Okay, and for all the 10 steps that we went ahead, right, we calculate the errors in each of them using this one only. Okay, so if you come here, wait, see here, so I did cross validations and everything. Now I'm predicting. Okay, so this is for the same thing. So region T, right, it gave a 0, but when I tested with that cross validation, see how much it is, 69,242. This is the amount of error it is giving. This means this trained, means it literally just memorized everything, so that when I gave this guy the new data, it was behaving so badly. See, so there are, means it's expected, it's not that we have done something wrong, it's expected. That's what is machine learning. Then we'll see how we can tweak something so that we can improve this value. Okay, so now, yeah, obviously fine tune your model because we need to perform well. So one, uh, usually till now it was all data data data. Now the model that we are using, right, it has also few parameters which we can tweak so that it performs well. Okay, so so here if you see, right, it's a very good example. So these were the points. Okay, so I need to have this blue line here. If you see, it's going straightly, it doesn't understand also this value somehow. Okay, here the values are going down then going up, it is also going down but not that much. Here see, it's going in the same line, that's blue line. Okay, here it has very strongly fitted. Okay, so each one has its own importance. Okay, if it underfits, if you say it doesn't understand which value, or if you're just giving, it is giving you some value not based on these values, okay, then it's also not good. If it is overfitting, that is also not good. It has to be somewhere in between. Okay, not overfit, not completely underfit. So for this we have difference here, degree. There is one parameter that it is given. So for every model, right, we have some parameter. So the this say decision tree. So for any model, right, we have different parameters. See here, there is one parameter as n estimator. Okay, one is max feature. So we are giving him different values. We are giving him different values, and what this grid search you will do is it will take all the combination 3 into 4, 12 combinations. Okay, on all of these model it will try to run this. Okay, this cross validation and give us the result. So if you run this, right, it will take some time, but after that you can see. Okay, n estimator 30. So out of these three, right, when it selected 30, and for the max features, where is the max features? Max features is 8. So when it took 30 and 8, it performed the best, whereas when it took 10, 4, or 3, 2, 3, 8, it didn't perform that well. The best it performed when it took 30 and 8. So next time we can think of increasing it. Let's say 40, this one as 10, because as the values are increasing, it is performing better. Okay, so that is one more way of achieving a bit better result. Okay, now at the end of the day, when, okay, we have got a model which is performing the best till now. Okay, we can do many tweaks, but till now, okay, Then we will try to analyze the model. Okay, what are the different features are behaving pretty well. Okay, so these are all the features that we have, all the columns. This means, okay, in the data, which one is playing major role in determining our mean value, that label that we are trying to find. Okay, so we can see, okay, 2 3 columns we are seeing which are performing pretty bad. Means if their values are changing, nothing is happening to the label. Okay, then we can think of the correlation, or somehow, you know, creating a group of out of them three and then seeing how our model behaves. So this is always a iterative model. We'll keep on doing changes to get better results. Okay, and later, till now it was all testing, sorry, training. Now it's time to test. So finally, with the same thing to that pipeline, first we will say transform. Why transform? Because all these things, the median and all. Okay, so test set, we have hidden it somewhere. Okay, it might also have some NN values, or this scaling would have been whole place, so it might have some categorical values also. So with the same thing, we will prepare the data here. So this is the data preparation. Then we'll take our model and then say predict. Okay, because it's already learned, right? It has to just predict. It gives the prediction. Then we are checking the score. This is something around 47,730. Okay, now once this everything is done, launch the model. Means it's not straight away we'll launch. We'll do more iteration of these three, so get the best result as we can. Then we'll launch the model. Then we'll monitor it. Then means monitoring usually means if some chunk data is given somehow. Okay, and our till now in our model it doesn't know something like NaN values or categorical or something. But if it happens that for a number column we are giving some text values or some chunk values somehow, or somehow the data that is fit in, the quality is not good. Okay, some other wayward values we are giving for the values. Okay, and but the problem is our model will try to predict and it will hamper pretty badly. Okay, so we need to keep on checking, okay, how it is behaving, keep in monitoring. If we say, okay, yeah, it again needs to train because we are getting some more data. Okay, so again we can bring it offline, train it, or online only we can help it learn it. So there are different ways we can do it. Okay, but these are the later stages. First, these all stages are pretty important. So this chapter, really, right, it was all data. So first I thought, okay, this is what it is. Everything should be in my mind, but there are so many things that later I understood. Just this chapter was mostly to give an overview of how those steps goes through for machine learning. Okay, from data preparation to value, visualizing the data, to cleaning the data, to giving it the model, to tweaking the model, and it's an iterative process. Okay, so this was just to give you an overview. Okay, so this was mostly the chapter 2. And now going through the exercises that are there. Okay, now this one is one more where I was going through. So till now I have reached somewhere around this plotting with pandas. So previously I have done this little bit pandas and numpy and matplotlib. So I'm going through. So I think someone who starts afresh, right, for them it would be very important because it teaches pretty well. I think this guy, this Daniel Borge, he explains this pretty well. Everything he will go from in depth. If you don't know anything also, right, you can start this is a good overview of things. I haven't been now to the Scikit-Learn supervised till this time. Teaches it pretty well, and this all I knew from before, so I haven't created any review sort of a thing for this. Okay, and for the maths also, finally I got a book. I heard that means most of them are recommending this, so I have just started. Means I've reached the first. Yeah, I'm going through this one, so you can see the highlights. So wow, this is just 2 3 pages. So once the next week I can review what all things I learned in here. Okay, so this was the week 3. This was a whole lot. I think this thing was a whole lot. So many information to keep in mind. I was always thinking, okay, what is going to happen? So I can't remember everything. But yeah, I mean, in most of the parts in the chapter, it's written that for now, just use these things. Later on in chapter 7, you will be understanding what you are doing. Something like this, like this N estimators and max features. What are these? So in some chapter 7 or 8, you will be learning this. Just now, they're giving an overview. So it's going pretty well. So thank you. Bye bye.